hypothesis testing for the mean of the population. Now let me bring this problem here. So if you take a look to the problem once again, you see we want to compare the Pittsburgh area with the whole population, with the national population. Now, in order to the magazine that the average groom age is 27.5 years for the whole nation, but specifically in Pittsburgh area, the number goes down to 26 years, according to 65 sample. Now, the question here is there enough evidence to say there is a difference between specifically in Pittsburgh and the national average? Right now, the first thing we need to decide on is if this is two-tail, left tail, or right tail. Now, since it doesn't say here Pittsburgh is less than or more than, but specifically say if there is a difference, then we need to do two-tail test. Now, then you need to pick here two-tail. If this was like, if Pittsburgh has less average than the national average, then we probably will use one-tail test. So let's put our data here. The null hypothesis, mu for population. So the hypothesis always for the population. So you don't test the sample because the sample is already known. Like for instance here 26 is the result for the sample. So we are not testing the sample, we are testing the population. So the population average was 27.5. Level of significance we want 0.01. Alpha is 0.01. Population standard deviation is 5.3. Sample size is 65 and the sample mean is 26. First of all, after we set up our hypothesis, which is here mu equals 27.5 or mu is different 27.5. The second step is to find out the critical values. So in order to find the critical values, we need to use Excel function norm SINV B5 divided by 2. The reason B5 divided by 2 because it's two-tail test, and then the alpha needs divided by 2. So alpha was B5, so 0.01 divided by 2, and if I click OK, I find minus 2.58 with norm SINV. It shows the left side. Now I want to find the right side, then I use the same formula, but this time norm SINV 1 minus B5. Instead of B5, 1 minus B5, so I can get a positive number. So well then, I know the critical values. Let me bring you the graphic for the critical values here. So you can see here the critical values are between minus 2.58 and plus 2.58. So once I find the test value, which is here minus 2.28, then I can decide on if H0 or H1 should be accepted. Now, any number between minus 2.58 and plus 2.58 will result with H0 accept, H1 reject, and any number beyond these points would be H1 accept, H0 reject. Now in order to find the test value, so I'm going to use this formula here, x bar minus mu. X bar is the sample mean, 26, which is B8, minus mu, which is the population mean, B4, divided by standard deviation, which is B6, divided by square root of sample size, which is B8. I'm sorry, B7. Now, once you do this calculation, you find here minus 2.28. So the formula is already written. Whenever you enter the numbers, you can find this result. So 2.28. 2.28 falls between minus 2.58 and plus 2.58, which tells me H0 should be accepted. And what does that mean? That means the Pittsburgh area, the H average for Pittsburgh area is not significantly different than the national average. With 99%, I can tell Pittsburgh has no difference than the national average.